Hello, this is part of my tutorial series. This is part 1. I used to have a series back then, but I deleted or I made all of the videos private. And as you can see, we are doing word generation today. This is another implementation I did 1.5 years ago, I think, or 1 year ago, I don't know, 1.5. And it uses my own Perlin function, not my own, one I found on the internet, I guess. But today, the Perlin noise function we are going to use is going to be in fast noise, a library. So you're also going to learn how to use libraries with Script API. And yeah, I'm not going to show you how to do the trees, the grass, because it's not really hard to do. You can just add that yourself. The only thing I'm going to give you guys is in basis on word generation, so the basic grass foundation blocks, and the rest you can do yourself, figure it out. It's a good learning experience, especially if you want to go deeper into word gen, as you can see. And yeah, it shouldn't be that hard today. We're gonna start from the ground up. So basically you could have zero experience with Scripts API, but one thing you do need is some JavaScript knowledge, because I'm not actually going to teach you JavaScript today, only Script API. So yeah, I hope you're ready to learn. So the 3 things you're going to need today is Node.js, and the one thing you especially need from this is npm, the Node Package Manager, for the typings of Script API. Especially as a beginner, you definitely need the typings or auto completions, so you can easily write Script API, because Script API isn't hard. It's a pretty decent API. It's a good one actually. It's easy to use. Then you need Visual Studio Code as a code editor. You can use any code editor actually, but Visual Studio has a really good inbuilt JavaScript support, and it's basically made for JavaScript, so it's easy to use. And you need the fast noise library for today. This is gonna be here, and also in the repository and on my GitHub. So I'm gonna kind of freestyle this tutorial video, so I hope it's gonna go well. This is a manifest.json, which you need, and if you don't have this, it's also in the description in my GitHub repository. And one important part about the manifest is the version number of the @Minecraft server module and @server UI, which you're not going to use. There's a lot more modules. There's like 4 or 5 different modules you can use, but this one is the most important one. So now what we're going to do with Node.js is actually set up the project. So you open up a new terminal, Control J, and after that you can type in your terminal. Let's make it bigger. npm, oh my god, bruh. Let's see, npm init -y, which basically initializes a new Node Package Manager project, and after that you will get the package.json. Here you can do npm I @Minecraft/server, and we only need @server, so that's fine. Let's get it back to the original size, which is this one probably. So after you have run this command, it will say this stuff here. And one thing you will see, you will have typings now, but they will be from the wrong version. So go to the, for you it's going to be on the left side, but go to the extensions tab. Like I said, for you on the left side, for me it's on the right. And on the extensions tab, type npm And about this, it's called NPM by Kasper Mikiewicz. I don't think I pronounced that correct, but download this one. And another one you have to download, or it's good. It's called UUID generator, this one. So grab both of these, and after you have both of them, first you can go to the right, or on the left I mean, for you, and press this cube. It's called node dependencies. You have your dependency here for your typings. So in this case it's 1.11.0. We can change it to 1.12.0 beta, 1.21 stable, which is the current version of Minecraft. And as you can see, this is the version we specified in the manifest. There's a lot more versions. There's stable versions, as you can see. And these stable versions, you can use stable APIs, script API, and you will never have to update your script ever again. But if you use beta APIs, you will have to update your scripts each time it updates. The main advantage to beta is that you have a lot more features. What you need to change in the manifest as well is the UUID. Like I said, before we download the UUID, we can highlight this UUID and press generate UUID at cursor, which we're gonna do for all of the UUIDs. And basically it uses these UUIDs to identify which pack is which. It doesn't actually use the name. So if you have two packs with the same UUID, it's gonna like break. So as you can see, we have a folder here in the manifest. We have scripts, type scripts, and entry point, which is scripts index.js. So we go to make this folder, scripts, and then there we make an index.js. I have the files here, but we're gonna have to move them into here. And actually, okay, that's fine. So we have the scripts folder now, and in here we have the fast node light, which I told you how to get. You can also get it from this. A pretty big file, but pretty cool. And in here, what we can do is import fast noise light from this specify JS. Now we can use this. So how we use this is we do const noise, we specify a noise, and we do new fast noise light, and we specify a seed, which we actually don't need to specify. And then what we can do, for example, with this noise now, is set its type. So noise.set type, set noise type, it wants, as you can see, it wants this thing here. So what we can do, fast noise light, noise type. You can name it however you want, but I just did it like this. And we want Perl noise. So these are the basics of fast noise light. So how we would get a noise now is noise.get noise and XYZ number. So basically for each coordinate. Exactly. So we can now expand this to Minecraft and do some world generation with this. In Minecraft Bedrock Edition, we're gonna now create a new world. And so the important thing, you can do this stuff however you want. Today we're gonna use a flat world, but the important thing is you go to the behavior pack tab, and you find your pack. In this case, it's called MCPE Learn GitHub repository. You can name the pack however you want in the manifest. And another important thing is you turn on beta APIs, because we're using a beta version. And this is the only thing you need, but I usually just turn on everything. But this is the only one you need, beta APIs. One important thing for world generation is turn on cheats, because, or especially script API, because you need to arrange it. You need to like reload, which I'm gonna go on to later. Slash reload is a pretty cool command, and put the simulation distance pretty high. So for convenience sake, we're actually gonna skip most of the noise library writing stuff, and I'm just gonna show you how I did it. Basically with the exact same setup I had on my other version, but with the fast noise library. So we first set some properties of the noise. We set the fractal octaves, which are the complexity of the scene. Then we set the fractal gain, which is when you have a lower fractal gain, it's smoother terrain, and high, it's more details, or it actually gets pretty rough. Then we set the overworld scale, which we are going to use later. We then specify a start point and an end point, so basically what we want to generate. And now I'm going to show the main part, the generate terrain function, which is this. And first what we do is like, you can't do a for loop if you have higher values on the start, and this like filters out the lower values to the start, and so the for loops work. This is like basically basic JavaScript, so you should know. This is the important part. So we have noise value, which is a variable which get noise.getNoise, x.overworld scale, and .y.overworld scale, because we don't need the y value, or we only need x and z, so we can just use the same y value because we only do terrain generation. And we have a z value times the overworld scale. Then we do some cool calculations to calculate the height, and then we're basically already done. So now is the script API part. If you're wondering where's script API actually at, so how you import script API or Minecraft Bedrock script API is import your imports. You can also import it like fast noise, but fast noise has a default import, and it's way better. In this case, it's better to destructure the imports here. But it's basically the class, and it's like the main import you need, because world has after events, before events, and everything. You can play with the world. So it has like, for example, we can look at after events. You can see item complete use, item use, chat, for example, chat send. But let's not bother with this. So what we first do is save the dimension. So we do const overworld, because we are interested in that. Set world dot get dimension overworld, like that. So this we do so we don't have to call the world dot get dimension all the time, which a lot of people do, but don't do that. Save your dimensions in the variables. Do overworld dot get block, and now it wants a location, which we can give it. So we have the height value here, we have x and z. So what we can do is x, y, height, and z, and we do dot. These are the block methods, so we can do set type, and then for example Minecraft grass. I don't know if it's grass or grass block, we can see later, but this is how you do it basically. And if you want to use fill methods, they did update that, so you can do overworld.fill blocks, and it wants a block volume base in this case. So how you do this, so new block volume, not block volume base, new block volume, exactly. So it wants a start vector and an end vector. So on this twice, and then you can fill blocks from one position to another. And block volume you have to import as well at the top here, which we're not using, so I'm going to remove it. This should be all the world generation code. And now you may be wondering, why did I use function star? Star is a generator function, and I can't really tell you why my microphone is cutting out, but basically what we're doing here is we're using system.run job, which in this case handles the performance for us, and like each time it doesn't lag, like if the word lags, it doesn't call the function anymore. So it, like I said, handles the performance for us, and you just give it a generator function with the parameters. And there's also another method which is called system.run interval, which I'm going to show soon, which runs an specific piece of code or a function in an interval which is specified in ticks. So everything works in ticks, and all of them use the system class, because the regular JavaScript stuff like set interval and stuff like that doesn't exist in script API. It's all done by the system class. So I did lower the noise value, the Y value, to 0. I don't know how much it actually affects the word generation, but it could. As you saw, I had the whole code commented out, and that I did so it doesn't like activate the code. So we can do game mode show coordinates. Sure. So we see where we are. Nice. So the word gen is gonna happen at, I'm looking at the top left currently, 0 to 100. So this direction. This is the reload command actually. I can show you. I do /reload, and now it should be generating. Oh, that's kind of high. And as you can see, it did generate. It doesn't look great at all, but we can fix that. The issue probably is the values we set are bad. So how do we fix this? We like play with the values here, because I did have the other polynoise function, so mine worked with these values pretty well, but in this case it's not working. So I'm gonna play with the values and then see and give you an update later. So I think I figured out something decent good. This polynoise function is actually kind of different to mine. I don't know how, because it's both polynoise, but yeah, I guess this one looks kind of worse, to be honest, but it's because you have to play with the values. Like I said, the ones I had before actually didn't like work like mine did, but you can set all of these stuff, and yeah, just type set and then you see like send your jitter, whatever that is. Okay, but what I have now is this, which doesn't look bad at all. Here you go, and you see these holes. This is because usually what you would do with word generation, which we didn't do yet and I'm not gonna do, is you fill the gaps down here with dirt, and this will make it way better. So like this, and then you have like proper word generation. But this is just like the basis, and as you can see, it's really fast. So I'm gonna like generate. And the one thing that's bad about Virgin is that it's like really, block placing is really slow. As you can see, it generates really high mountains. So this is like, you can probably change it to not do this, but I guess you have caves and cliffs now. And like I said, play with the values, and even put some in the comments, maybe on my Discord server, if you find any cool combination with values. Maybe check out some how Minecraft does it, and you'll see. Maybe even try using your own implementation of pellet noise or another one you find on the internet. But the concept is the same. So you have the exact same thing. One thing I did add is try catch for overworld get block set type, because if you can't get the block, it will like stop the script completely. And if we do this, even if some blocks are unrendered, it's still just gonna continue because of the try catch. But as you can see, this is what we got today. It's extremely hilly, which I don't know. You can probably fix with changing the values, like I said. And if you can't, just get your own implementation of pellet noise. Because I also never used fast noise. Today was my first time. So I had to like play with it as well. But this is what I got. And if you put down some trees, you can make a cool biome with this. You can even go way complexer, make biomes like temperatures or whatever. Water isn't that hard. How Minecraft, I can tell you how Minecraft is water. So they have a set height. I think it's like 62 or less. And at that set height, they place water. Okay, I did manage to make it not so steep, and I'm stupid because I do have a height modifier here. This I had set to 64, which was kind of stupid, and I didn't even notice, to be honest. But this is how the height gets calculated. So if you put this modification lower, it's gonna make it not so steep. And also the overworld scale variable, I put that a little higher. And we can check. This is me trying some stuff out. As you can see, beautiful version. So when we reload now, it should be really flat or kinda. As you can see, it really lags my game, but yeah. As you can see, this is still pretty hilly, but we can kind of like see it's not as hilly anymore. And like I said, lower these values and you will get like extremely flat generation. So 16, and this can say the same. Oh shit. Gotta change the coordinates first. You can also like automate the system. But yeah, as you can see, now we have the extremely not hilly at all. It's really laggy generating. It's placing so many blocks that it's laggy. There we go. We got regular generation now. So yeah, this is how you make it better. The other values I had back then, you can keep them. I don't know how they affect the thing. Like I said, I never used fast noise, but yeah. And also, like I said, you can watch tutorials on Berlin noise on YouTube. There's probably really good explanation out there. And yeah, this is how you write a pretty optimized terrain generation. Like I said before, put the fill block so it fills blocks underneath. This is like one layer. Yeah, it's pretty easy. It's not hard at all. It took pretty long because I'm stupid. But yeah, that was it. Goodbye, guys.